Okay, so the question had something like this, where these two lines were parallel.
What are we taking this up?
Just that one question. And you have two triangles, right?
Yep. And then you have like 43 on the top.
So I gave you one angle, I'll call it A. I gave you another angle, we'll call it B.
These already given.
Yes, so those are two angles I gave you, A and D. And you had to prove somehow that these triangles were similar. Okay, so first of all, because you have two intersecting lines, this angle has to equal A. Well, degrees of a triangle out to 180, so this angle must be 180 minus A minus B. Okay? Problem is, what are the angles of the two triangles? If we could show that those two angles are the same as the other two, then we'll have equivalent triangles. Okay? So now if I extend this line, extend this line, so now I have something that looks like this. Now if I only focus on this line over here, so extend it like this, we get something that looks like that. Pretty close. This is my angle B. Right?
Yeah.
That maps to this angle here. So what's this angle? Well, that first question on the test, we know that this angle is the same because it translates down, and because of opposite angles, that's B. So we're seeing the same thing that's happening over here. This is B, so this is B. So finally, same thing, you can do it this way for another angle, or basically this is also 180 minus A minus B. So because all three angles of your triangle are similar, are the same, your triangles must be similar. Now you can use the fact that because they're similar, the sides are proportional. Miss Sabrina.
For B, can you also do like the Z thing? You know when like it's Z and then like
Z. So the Z, yeah. So as long as you try to explain to me that this angle and this angle is the same, with some people said the Z thing, I accepted that. I knew we were trying to get at. Okay. If you try to use size to prove it, you're automatically off the wrong path because you weren't given all the sides of the triangle, nor can you figure out all the sides of the triangle. So you can't prove that they're proportional. Okay? Questions on that? So that one was hopefully somewhat, you know what, I look back at the Google Doc that Ms. Stevens set up for us. The question was right out of there. It was inadvertent, but the question was right out of there. Prove that these triangles were similar. Okay. So today, last thing that we're going to take up explicitly before, last thing sort of need to know, although you know all this information already, is solving problems with right angle triangles. Okay, as you encounter some of these problems in the textbook, you okay?
Yeah.
There's a couple of definitions that you kind of need to be aware of. So write down these definitions. So we have the angle of depression. It's also known as the angle of declination. That's the angle measured below the horizontal. angle measured below the horizontal. Conversely, we have the angle of elevation. So angle of elevation is also known as the angle of inclination. And this is the angle measured above the horizontal. You don't have paper anymore? Could somebody lend Haley some paper? Thank you, Eric. Oh. Okay, so here's a diagram to sort of help you visualize what that means. Okay, so we can kind of treat, I'll let you copy that diagram first.
No, not about there.
Okay, the whole idea of hopefully that the terms make sense to us. Depression, we think of depression, we think about it's feeling down, right? So how they being down, we had the stock market crash in the 1950s, they called it depression, right? So it's the fact is downwards. So if I'm looking, if I was standing on, if this was like the top of a building or something, right? And I'm looking down, right? It's almost like how much do I have to tilt my head? What's the degree that I have to tilt my head? If my eyes are parallel to the ground, that's the line of, that's the horizontal line. So how much down do I have to look? So that's the degrees that you sort of have to look down. Although most of the time we're referencing to the base, so like feet, like let's say, right? If I'm standing there. So it's the degrees down from the bottom of my feet horizontal, right? Elevation, right? Thinking about upwards, elevator, right? So angle of elevation is like how far I have to look up. So I was looking up at a mountain or a tall building or the plane in the sky or something, right? What angle from my feet up is there from the ground? Okay, so that's sort of like the two meanings of those definitions. Any questions on that? Kind of straightforward. Will you be asked to define this? No. Nothing actually for the definition. So are there going to be word problems that use these terms?
Yeah.
Yeah, so that's why you sort of have to know the meaning. So here's an example. Okay, it's supposed to be super bad. Lauren and Lois are facing each other. So write this down. What I like about you actually writing down the word problem is that as you write, you can actually process the words. Think about what the question is saying. Think about what's happening. So Lauren and Lois are facing each other on opposite sides of a 10-meter flagpole. From Lauren's point of view, top of the flagpole is at an angle of elevation of 50 degrees. From Lois's point of view, it is 35 degrees. So how far apart are Lauren and Lois? iPad, because I need some power.
Computer or iPad?
Well, your computer wasn't plugged in with your iPad and your phone, so I chose the less important option of your iPad.
Okay, no problem, thank you.
I'll plug it in, back it up.
Whatever, yeah, it's good.
So where do we, any application problem? Where do we start?
Picture.
Thank you. Always start with a diagram, right? How do we turn our words into visual? Okay? So what are you going to start off with? Flagpole? Looks like that. You got a ball on top. I don't know. Right? Well, the flagpole's got to be stuck to something. The ground. Sort of flag? Okay.
That's the American.
Yeah,
Sean.
I feel assaulted now.
Yes,
What kind of flag is that? Is that supposed to be police?
It kind of does. It kind of does.
Looks like.
Use your imagination.
Anyways. See? You know what? The important point is not the details in your diagram, okay? Although, you know, it kind of adds to the fun.
Yeah, I still have to buy.
So if you want to do it for homework, that's fine. I don't recommend doing it on the test, because you do have some more time.
Draw my masterpiece of it.
So what else is part of this picture?
Lauren and Lois.
Alex?
Well, you have to try, I don't know, like maybe 2 lines to represent the people at different distances.
Well, let's draw the people. So who's involved here? Lauren and Lois?
Sean and John.
John and John? Yeah, so Eric, where are we gonna draw Lois and Lauren? Like where are they relative to one another, or
They're on opposite sides.
so they're opposite sides of the flagpole. So in other words, one person's on one side of the flagpole, the other person on the other. So we'll draw.
Securely.
Okay, I have to give her a body at this, right?
Doesn't need one.
There we go. She could have some long curly hair, long straight hair. So this is Lauren, and then Lois would be over here. She's got a funky do, right?
One massive hair sticking
Sure. Bunch of massive hair sticking up.
She's talking.
Trying to imitate a little beehive. You remember the beehive?
That just looks like Marge from The Simpsons.
Yeah. Okay.
Wait, what was that?
So this is Lois over here. Okay. So the idea is we have a perspective of where they are. What else is the words telling us? What about the angle, Jack?
Ankle, I don't know how to say it, you know, bottom angles of where they are,
Of who first?
of the Lois.
Of Lois?
Whatever.
Well, you tell me.
Okay, so Lois is 35.
So Lois, so let's talk about from Lois to where?
To the top of the flag.
So we'll go from the top of the flagpole to Lois.
Sounds really straight.
Getting better, I'm getting better. Right? So what about that though?
30 angle at the bottom.
The angle at the bottom, so I'm talking about the angle of elevation
Angle elevation.
is 35 degrees.
It's the same for Laura, that was 50 degrees.
So same for Lauren, for hers is 50 degrees. So this is 50. Anything else that we could sort of imply from this diagram?
Is the flagpole vertically straight?
Flagpole's 10 meters.
Good question. Is it vertical straight? Sabrina?
It's 10 meters.
Okay, so the other thing was the flagpole is 10 meters.
And I'm gonna say that the flagpole is not tilted.
Sorry?
Flagpole's
Flagpole is not
What
tilted.
if it's a windy day?
So the thing is,
Flagpole
so the question is, if the flagpole is not vertically straight, can you answer this question?
No.
no.
So you tell me. Okay, you know what? I'm assuming that there is a right angle triangle there. Because the flagpole,
But how are you supposed to assume?
do we tell you?
No, someone accidentally kicked it.
That's right.
But we're just saying in order, what you're saying is that in order to answer this question, that's gonna be a right angle triangle. If it's off by 0.001 degrees, that could affect my calculation tremendously? No. It could, but not in this case, right?
It's not that.
Take your shot. You want to solve it some other way without a right angle triangle? Be my guest. Alright, that's all I can say. What is it that we're trying to solve for though? Tyler.
How far
How far apart are they? So we're really looking for this. Right?
This is gonna take a while.
Is it in meters?
You just gotta find
Well-
two
Well, yes,
sides.
10 meters.
No, what is the distance
Well, we can answer it in meters. We can answer in kilometers or millimeters. So how do we get that distance?
You can find both the
Uh,
both the bottom sides. You know, I know how to do it. I'm just not good at
You need
explaining
to
it.
find-
That's what we're looking to practice on, Zach.
Okay.
Well, let's give Zach a chance.
Oh, okay.
So, what is it that we want to do, Zach?
Find the tan.
Well, even before we
Okay.
get tan or sine and cosine,
You want to
how
find.
can we break down our problem?
So it's each side of the flagpole. On the length.
Yeah, so we can find the length from Lauren to the flagpole. We'll call that X. And we can find distance from the flagpole to Lois. We'll call that Y. So really, this distance here is just X plus Y. See, the reason he kind of, Zach is seeing ahead, he knows what he needs to solve for. So let's just break that down. And so, well, really, we want to know this distance because that's one right angle triangle. And then we want this other distance because, which is y, which is the other part of the right, which is another right angle triangle. Are these two triangles similar?
Yeah. No, probably not.
Well, if this is 50, what does that have to be?
Oh, that's 60, 30.
This has to be 40, right?
They still can't.
So they're not similar because if this is 35, this is 55. So we can't do ratios. Well, what is it that we can do though?
10.
Tan.
Good old tan.
So let's do the green triangle.
Got it, Mr. Taz.
30 just a 10.
I really want to call this trick question TAM, really. I think it, maybe I start a petition. Give me a TAN ratio.
Can we do it in
So what's tan of theta?
Opposite over adjacent.
Okay, so always start off just with your equation, opposite over adjacent, and then you can start filling in what we know. Do we know theta?
Yeah.
What is theta here?
35.
Sorry?
50, whatever. 30, 50.
We're doing this
I don't know what angle we're talking about. Okay.
We're doing this one, tan of 50.
Equals 10 over x.
So opposite is
Over A,
10,
adjacent A.
and adjacent
Side
is
x
x.
rule.
Alright, I do Z.
Okay, So here we have solve for x. So x is 10 over tan of 50. Right? So in other words, I multiply both sides by x and then divide by tan of 50. So what's 10 divided by tan of 50?
8.39, so
8.39.
8.49.
Okay? If I don't specify decimal, like how much around, just stick with 2 decimal places. This could be?
It's supposed to be 60, not 40.
I just drew it 120.
Sorry? Where
It says on the triangle, it says 40, it's just supposed to be 60.
was 50 plus
Oh,
40
it's
is
50.
90.
It's 60 on the other.
Oh, right, yeah, okay. I thought it was 30.
So here we know that x is 8.39. And we go off and solve y in a similar fashion. Right, so here tan of 8, we use tan again because here we know the opposite. We need to figure out the adjacent. So we're using tan of beta, opposite over adjacent. So tan here of 35 is 10 over 8. Sorry, not 10 over y. We call that side y. So y is equal to 10 over tan of 35.
14.3.
So plug that into your calculators. Yeah, 35 on the other side.
It's 14.3.
Sorry, 14.5?
14.3.
14.3?
Yeah.
Got it to 2 decimal places? 14.29.
Yeah, okay. No.
Precise.
So therefore, we have x plus y equal to 8.39 plus 14.29 plus 22.68.
So close.
So therefore they are 22.68 meters apart. Okay, so there's sort of an application problem using trigonometry. So here we just have to break up our problem, get those 2 right angle triangles. Okay, any questions on that? So another question that tends to get confusing.
I just said that all of these
I said confusing.
No, I'm talking about
So here we have a scuba diver swam north. Scuba diver swimming north at 1.5 meters per second. But she's swimming across a current running east to west at 2.0 meters per second. She swam for 3 minutes and then surfaced.
So it's like the airplane question.
Yes. So I want that's why I want to give an example of a question that has directions in it. So the first part is just draw a diagram showing where she surfaced relative to where she dove. So the first thing that I do with these types of questions, and I recommend you do, not draw the picture yet, but just to orient ourselves. What I mean by orient ourselves is just figure out where northeast, southwest is. So I normally think of north as pointing up, south pointing down, and because of that, then east is to our right, west is to our left. Okay, so just orient ourselves first. You do this right at the start of the test. You got 1 plus orientation. It's fine too. So now we start thinking about what would happen if this diver, she jumped straight into the water, didn't swim, kind of bobbed there. floated there. What would happen to her? She get carried by the current, right? So how is she moving then? She's going from east to west, so she's sort of like moving like this way. How fast would she be moving? 2 meters per second. Okay. Let's say she jumped in a pool where there was no current or anything, and she swam due north at 1.5. So, which direction would she be going? Straight up. Right? So there was no current, she would go straight up at 1.5 meters per second. Yes, sir?
Swim north first.
You mean this? It sort of does. You just have to shift it on what happens because the reason I did it this way was because if she started here, if she current's being pushed this way and she's swimming up, her net location where she winds up is somewhere over here. Okay, so it's because she's going to wind up on the northwest side because the current is going east to west. Okay, so that's sort of how you kind of draw that diagram where she winds up. Honestly, I'm not a fan of these questions because I don't know if physics even makes sense in this. I don't know. I think it does. But what these questions do kind of prepare you to do is once you get to calculus, you do a lot of things on vectors and forces. And this is exactly how you do this stuff. They try to simulate that with planes and ships and all this other
Like you
stuff.
said, she's in a current, so you would have to consider
Yeah.
her
So
being pushed back. It's not optional, but
well, she's being pushed. So you look at this is the diver. She's trying to swim north, so she's going like this, but she's getting pushed. Right? So she's swimming. She keeps her body straight north all the time. So she's going, but she's getting pushed. So that's where she kind of winds up. Okay. So the question is, another question is, how far does she travel? So how do we figure that? Well, does north-east meet north-south at a right angle? So we can assume, in fact, let me assume it is a right angle here. That's why these questions will only be straight north-south, east-west. Right? Because those meet at a 90-degree angle. Next thing you know, it'll be a lot harder once you deal with not so straightforward. Or not 90-degree angle stuff. So how do we answer the question of how far did you travel?
Just throw it out here.
Go ahead, Zach, throw it.
Wing it. Just gonna wing it. So if you have to find one of the angles, or am I wrong?
Okay, what will finding the angle get you?
So that you can do the
On the other side.
cosine or sine of that angle on hypotenuse.
Yeah,
But
okay.
then we
Doesn't
don't
matter.
have
Doesn't matter.
hypotenuse.
It's more fun.
So things
So,
are great.
so Zach
I
just
agree with
went
that. Math is fun.
all the way to the GM3 and came back to get to Miss McGowan's class. It can be done. So yes, there's nothing wrong with that. Is there a faster way that we can get that though?
Yes.
So, yes, Zach, you can calculate the angle and then calculate the angle using tan, using that angle, and then using sine or cosine to figure out how else can we figure out the hypotenuse? Eric.
Can't you just convert seconds to meters? I mean, seconds to minutes?
Yeah.
Minutes and you just change it up.
Oh yeah, that's what I did on the.
Well, so we'll get back to your point. So Eric's first let's convert to time.
60 seconds.
So 3 minutes equals how many seconds?
I think.
Well, 3 times 60 seconds gives us 180 seconds. Right? So 3 minutes, 180 seconds. So if she was in the water for 3 minutes, how far would the current take her? from east to west. How far would the current take her this way? If she was in the water 3 minutes. There.
I already did it the other way.
Okay, but just
360.
well, it's 2 times 180, right?
90.
So 2 meters per second
Oh, wait, no, I'm-
times 180 seconds gives us 360 meters.
oh, no.
If she just ran straight, if she was just swimming due north, how far would she travel in 3 minutes? 1.5. So 1.5 meters per second times 180 seconds gives us 270 meters.
Now it's
So basically we have something that looks like this. How can we get that distance? Yeah. Right? Just because you taught you sine and cosine and tangent and all that doesn't mean that you throw everything else out the window. Right? We just do a squared plus b squared equals c squared. So what's 360 squared?
Mr. Tech, can't you do without converting it into like converting it to seconds?
We'll get to bring that up after we solve this. So really this is just the square root of 360 squared plus 270 squared. Put that in your calculators. Should get up to 450 exactly.
Doing 2 meters per second and then 1.5.
So another way you can look at this problem is that here we're talking about the vectors or the directions, talk about speed. So here the current's carrying 2 meters per second, she's swimming 1.5 meters per second. You can look at this part as what this is her net speed, but both the current carrying her and her swimming. And you apply the same thing, Pythagoras theorem of 2 squared plus 1.5 squared, take the square root of that, we get 2.5.
Yeah, 2.5.
So here you get 2.5 meters squared. You take that 2.5, multiply by 180, you get 450. So you get the same answer, right? So that's the cool thing about math, how you see the problems. You can see it that way and do it. Or you want to go back to how I did it, you want to do the measurements first, the distances first, come up to the same answer. Any questions on this specific example or questions in directions? Yeah, I don't need to use angles. So you see that, Zach? I don't need to use angles. You could, you probably would have came to an answer that's very close to 450. You would have lost some precision once you start dealing with the angles.
Those technical marks.
Honestly, if you did it that way, I'll probably give you full marks.
Keep that in mind.
Yeah, Max. Mr. Tech,
Yes,
can you take a water, please?
in a second.
It's gonna do this.
So this is homework.